There are many different approaches to teaching computer science. Some first courses focus on applications. Some focus on a programming language. This one focuses on programming paradigms and also programming languages, but with a strong emphasis on problem solving. There's one textbook called How to Design Programs that actually just focuses on the process of correctly defining a function. It's a great textbook. It doesn't cover nearly as much technical material as 61A, but the authors have thought carefully about how to teach the process of problem solving. So I thought I would do something unusual and share with you what they wrote about an effective process for solving a problem, meaning defining a function that has a particular behavior or achieves some particular goal. Here's what they wrote, and here's a link to the textbook in case you want to read it. It's free online. They say that there are 6 steps in designing a function. First, you have to set up your data definitions. Identify information that must be represented and how to represent it. On an exam, you rarely have to do this, but it has shown up in all of your projects. Information would be a description of a restaurant, and how it's represented, well, that's where we use data abstraction in order to build a dictionary or a list or whatever data actually represents the information that we want to manipulate. So they say in this stage you formulate data definitions and illustrate them with examples. Next, write the documentation for the function you're going to define. Signature, purpose statement, header. State what kind of data the desired function consumes and produces. We've talked about that in this course. It's domain and range. Formulate a concise answer to the question what the function computes. That's the one-sentence docstring that describes the behavior of the function. And they say define a stub that lives up to this signature. That's writing the def statement's header that shows how many arguments the function takes and gives them appropriate names. Step 3. Functional examples. Work through examples that illustrate the function's purpose. An important step, not to be omitted, that comes before writing any code. Step 4. Function template. Translate the data definitions into an outline of the function. Their suggestion of a template involves writing down the control structures you're going to use. Is the body of the function an if-else statement? And if so, what's the if condition? They also suggest writing down what function calls you're going to make within the body of the function, even if you don't know exactly where they're going to fit into the final code. Which is quite similar to what we did in the previous example when we wrote down the key expressions that were going to be used somewhere in our implementation. Finally, the function definition. Fill in the gaps in the function template. Exploit the purpose statement and the examples. And step 6 is testing. Use the examples as tests and ensure that the function passes all the tests. Doing so, it discovers mistakes. And they supplement the examples in that they help others read and understand the definition when the need arises, and it will arise for any serious program. So they're making the point here that you write programs not just to be executed, but for other people to read. A key feature of the process they describe is that it's example-driven. You don't decide what function you're going to write and then write the code for that function. Instead, you figure out early on what the data represents. This number is the length of the side of a rectangle. This list contains all the numbers that I'm allowed to add together when I build a partition, whatever it is, for solving the problem you want to solve. Then, when you think about your implementation, don't just think about it generally, but instead focus on examples that you've worked through in order to illustrate the function's purpose. Want to know what function calls to make and exactly how to make them? Think about an example. Now, I don't think this is the one perfect way to solve all problems, but I do think that it's a thoughtful description of how you might go about solving a problem that when you first think about it, you don't know how to solve. And so I thought I would share.